Hello class, today we will continue chapter 13, voting and apportionment, with 13.2 flaws of voting methods. Our objectives today are to use the majority criterion to determine a voting system's fairness, use the head-to-head criterion to determine a voting system's fairness, use the monotonicity criterion to determine a voting system's fairness, and use irrelevant alternatives criterion to determine a voting system's fairness, and to also understand Arrow's impossibility theorem. Now let's take a look at the majority criterion. It states that if a candidate receives a majority of first place votes in an election, then that candidate should win the election. Example 1, the board account method and how it violates the majority criterion. So we're going to show an example where the board account method violates the majority criterion. If you can't remember what the board account method is, please review your material from chapter 13.1. The 11 members of the board of trustees of your college must hire a new college president. The 4 finalists for the job, E, F, G, and H, are ranked by 11 members. The preference table is shown below. The board members agree to use the board account method to determine the winner. Which candidate has the majority of first place votes, and which candidate is declared the new college president using the Borda method? Okay, so let's look at which candidate has the most first choice votes. So if we look at the chart here, we've got our first choice here. We see E has 6 first place votes, G has 3 first place votes, and F has 2 first place votes. Now, in order for a candidate to receive the majority of the votes, remember that they need to receive over 50% of the votes. If there are 11 voters, 11 times 50% is going to give us 5.5. Remember, we have to round up to have a whole vote. So if we round up, a candidate needs at least 6 votes to have the majority. Okay. E does have 6 first place votes, so E should win the election by majority. But let's look at the board account method and see how it violates this. So using the Borda method with 4 candidates, a first place vote is worth 4 points, a second place vote is worth 3 points, and a third place vote is worth 2 points, and a fourth place vote is worth 1 point. So if we go through the chart here, it's the same chart that we have over here, but we're accounting for this point system with the board account method. So we're multiplying the 6 times 4, 6 times 3, 6 times 2, 6 times 1, 3 times 4, 3 times 3, 3 times 2, 3 times 1, 2 times 4, 2 times 3, 2 times 2, 2 times 1, using that board account method to get our totals here, which you can see in the chart. Okay, what we see here is that if we total these totals up, remember, like I said, if you need to review the board account method, please go back to 11.1 or 13.1. If we look at the totals for E, we're looking at 12. I'll do one of them. Look at the totals for E, we're looking at 12 plus 3 plus 2. Okay, so E has a total of 29. F has a total of 32. G has a total of 30. H has a total of 19. We total them in the same way. We just have to go back to the chart and look at them piece by piece. Okay, using the board account method, F should win this election because candidate F has the most points. Candidate F is declared the new college president using the Borda method. But remember, for this to be fair, it needs to pass the majority criterion. And in this case, it doesn't. Okay, it does not pass the majority criterion. Okay, because the majority criterion would say that, hey, the person we found in part A, which is E should be the new college president with the majority criterion, but the board account method directly violates this because it nominates candidate F. Okay, let's look at the head-to-head criterion. If a candidate is favored when compared separately, that is head-to-head with every other candidate, then that candidate should win the election. Okay, so we want to look at the plurality method and how it violates the head-to-head criterion. 22 people are asked to taste test and rank 3 different brands, A, B, and C, of tuna fish. The results are shown in the table. So we have the number of votes, versus first choice, second choice, and third choice. Okay. Which brand is favored over all others using the head-to-head comparison? And which brand wins the taste test using the plurality method? Okay. So we want to compare brands A and B. A is favored over B in columns 1 and 3, giving A 12 votes. B is favored over A in columns 2 and 4, giving B 10 votes. Hence, A is favored when compared to B. Okay. All right, so what did we just do? We're comparing brands A and B. Okay. All right, so if we compare A and B, here A wins out. Here B wins out. Here A wins out. Here B wins out. So essentially we have A, B, A, and B. And what we notice here is 8 plus 4 is 12 for A. And then we're doing 6 plus 4 for B, for where B won. That's 10. So here, A is the winner when compared to B. But we also need to compare brands A and C and brands B and C. Okay. If we compare brands A and C, A is favored over C in columns 1 and 4, giving A 12 votes. C is favored over A in column 2 and 3, giving C 10 votes. Hence, A is favored when compared to C. Now, if A is favored to both B and C, then it doesn't matter if B is compared or favored over C because A is favored over both. So we can actually kind of stop here. Now, like I said, notice that A is favored over the other two brands and using the head-to-head competition, so A should be the favorite overall. Okay, using the head-to-head criterion. But if we use the plurality method, the brand with the most first place votes is the winner. Since A received 8 first place votes, B received 4 votes, and C received 10 votes, brand C wins the taste test. So let's go back here. So using the plurality method, it should be the brand that wins the most first place votes. I'm going to change the color of my pen real quick. Let's change it to green. So C wins 6 votes and 4 votes here. So C wins 10 votes for first overall, while A only wins 8 votes overall for first, and B only wins 4 votes overall for first. So using that plurality method, C would win overall. So C fails the head-to-head criterion because it's using the head-to-head criterion, A should have been favored to win. So right now the plurality method violates the head-to-head criterion. So we're busting through these voting methods that we went through last time to see if any of them are going to pass all these criterion that we need to go through. And so far, the plurality method has failed. And back here in example 1, the board account method has failed as well. Okay. Let's look at another criterion, the monotonicity criterion. If a candidate wins an election and in a re-election the only changes are changes that favor the candidate, then that candidate should win the re-election. Okay. That's the monotonicity criterion. Okay, so we're going to look at the plurality with elimination method and how it violates the monotonicity criterion. Okay, if you need to review what the plurality with elimination method is, go back to 13.1. The 58 members of the Student Activity Council are meeting to elect a keynote speaker to launch Student Involvement Week. The choices are Bill Gates, represented with a G, Howard Stern, represented with an S, and Oprah Winfrey, represented with a W. After a straw vote, 8 students changed their vote so that Oprah Winfrey, W, is their first choice. Okay, so what you see in the chart on the left is the number of votes with your straw vote, and what you see on the right is the second election. Okay, notice here that these 8 voters changed their ballots to make Oprah Winfrey their first choice. Okay, so here's what we have. All right, here's what we have. We want to use the plurality with elimination method, which speaker wins the election. We'll find that out. Using the plurality with elimination method, which speaker wins the second election. And we want to see if this violates the monotonicity criterion. So let's break them down. Since there are 58 voters, the majority of the votes has to be 30 or more votes. No speaker received the majority of the votes in the first election. So we eliminate S because S had the fewest first place votes, and the new preference table is below. Okay, let's go back. All right, so S received the fewest first place votes here because W received 20, S received 16, G received 14 plus 8. So G had more first place votes than S. So we're going to eliminate S and move everybody up. Okay, the plurality with elimination method. So this gets moved up to a W, this gets moved up to a G, this gets moved up to a G, this gets moved up to a W, this gets, well, that one stays the same. Okay, and you have the new chart. Okay, just a little refresher on how to do that. If you need to, a little bit more refresher, go back to 13.1. Okay, this is our new chart here with our first choice and our second choice, basically comparing W's and G's. Okay, this is what we see. Okay, so we see now that W has 20 votes and 16 votes, and G has 14 votes and 8 votes for first place. Okay, so 20 plus 16 is going to give you that over 30 majority there. So since W received the majority of first place votes, 36 votes, Oprah Winfrey is the winner of the straw vote in the first election. Now in the second election, the only thing that changed was more people voted for Oprah Winfrey to be first. Okay, so if that's the case, surely she'll still win first, right? Well, let's look at it with this plurality with elimination method. Again, we look for the candidate that has received the majority of the votes, 30 or more. We see that no candidate has received the majority of the votes in the second election, so we eliminate G because G receives the fewest first place votes. The new preference table is. Okay, now in the second election here, I'm going to go back to this slide. In the second election, W now receives 28 first place votes after this re-election, while S receives 16 and G receives 14. Okay, so clearly G has the fewest amount, so we're going to eliminate G overall. And then we're going to adjust our tables accordingly. So all we're going to do is S and W there. And our new table is right over here. Okay, now we see that W has 28 first place votes, and S has 16 and 14, which total to give 30 first place votes. Okay, because we have 58 voters overall, with 58 voters overall, we need 50% of those, more than 50% of those to have the majority, right? So if we multiply that times 0.50, and then we round up, we see that that would be, just a refresher, so that would be 14, and we need to round up to 15. That's where that 15 comes from. Oh, sorry. Oh, wow. That's terrible math, Mr. Shipes. So 58 times that would be, sorry, that was what, 29. Whew. Been a long day. So to round up, we need to round up to 30. Wow, that was terrible. Ignore that, right? So 58 times 0.5 is 29. We round up to 30. So that's why if we receive 30 votes, we've received the majority. Here, S has received the majority of votes, 30 exactly. So Howard Stern is the winner of the second election, which makes no sense, right? Because Oprah Winfrey just got more first place votes in the second election. So how in the world, if she got more first place votes, did she wind up winning or losing when she had won the election on the first go around with the most first place votes? Makes no sense, right? That's why it fails that monotonicity criterion. Okay. Oprah Winfrey won the first election. She then gained additional support with 8 voters who changed their ballots. However, she lost the second election. This violates the monotonicity criterion. Means it's not really that fair. The irrelevant alternatives criterion. If a candidate wins an election, and in a recount, the only changes are that one or more of the other candidates are removed from the ballot, then that candidate should still win the election. Okay? So we want to look at the pairwise comparison method and how it violates the irrelevant alternatives criterion. We have 4 candidates, E, F, G, and H, are running for mayor of Billinius. The election results are shown. So we have the number of votes in the top column, first choice, second choice, third choice, and fourth choice. E, F, G, and H listed. We want to use the pairwise comparison method and see who wins the election. And then prior to the announcement of the election results, candidates F and G both withdraw from the running. Using the pairwise comparison method, which candidate is declared mayor of Bolinas with F and G eliminated from the preference table? Does this violate the irrelevant alternatives criterion? Okay, because there are 4 candidates, n equals 4. The number of comparisons we must make, remember this formula from 13.1, C equals n times n minus 1 over 2. We need to plug that 4 into that and see that we need to make 6 initial comparisons. Okay, like I said, if you need to review the pairwise comparison method, go back to 13.1. So we're first going to compare E with F, then E with G, E with H, F and G, F and H, and G with H. Okay. Now, doing this, we see that 260 voters prefer E to F, and 100 voters prefer F to G, so E wins and gets 1 point. If we look at E versus G, 260 voters prefer E to G, and 100 voters prefer G to E. E wins and gets 1 point. If we look at E versus H, 160 voters prefer E to H, 200 voters prefer H to E. H wins and gets 1 point. If we look at F versus G, 180 voters prefer F to G, 180 voters prefer G to F. It's a tie. F gets a half a point and G gets a half a point. Oh wow, we actually went up with a tie. Interesting. F versus H. 260 voters prefer F to H, 100 voters prefer H to F. F wins and gets 1 point. G versus H, we have 260 voters that prefer G to H, and 100 voters prefer H to G. G wins and gets 1 point. Thus, E gets 2 points, F and G get 1.5 points, and H gets 1 point. Therefore, E is the winner. Okay? So in our initial tally here, using the pairwise comparison method, E is the winner. Like I said, if you need a review of the pairwise comparison method, you're going to have to go back to 13.1. Okay? All right. Remember, that's where we kind of go through here, like if we're comparing E versus F, right? E versus F. E beats out F in the first column. That's where it gets the 160 from. F wins the second column because F is the bigger one than the E right here. So in this column, E beats F. So we get 80. E beats F, we get 20. So this is your E. This is your E. This was the 160, and that's where we saw this number here of 260. Okay, just a short little review there. But in part B, remember that F and G withdraw from the running, and now with only 2 candidates, E and H, remaining, the number of comparisons we must make is simply just 1. If we plug 2 in this comparison formula here, 2 times 2 minus 1 over 2 is just 1. So we really just need to compare E and H, obviously. If we compare E and H, what we see here in our tally chart is that in our first comparison, E gets 160. In our second comparison, third comparison, and fourth comparison, H gets 100, 80, and 20 respectively. So H gets 200 voters in this comparison. The one comparison we need to make is E versus H, since 200 voters prefer H to E. H is the winner and is the new mayor of Bolinas, which makes no sense, right? Because the only thing that changed is somebody withdrawed, or 2 people withdrawed in this case. And now, because those people withdrawed and we eliminated those votes, then we see that E is no longer the winner, H is now the winner, which is obviously not fair and an issue because it violates the irrelevant alternatives criterion. Okay, the first election count produced E as the winner. When F and G were withdrawn from the election, the winner was H, not E. This violates the irrelevant alternatives criterion. So, we want a fair voting system. And so far we've seen that all the voting systems we put up and learned about in 13.1 violated some of the fairness criteria. So it is mathematically impossible for any democratic voting system to satisfy each of the 4 fairness criteria. The 4 fairness criteria we just reviewed in this lecture. If something could satisfy all 4 of them, we can consider it a fair election. Each of the voting methods we reviewed in 13.1 is flawed in some way or another and violate at least one of these fairness criteria. In 1951, economist Kenneth Arrow proved that there does not exist and will never exist any democratic voting system that satisfies all of the fairness criteria. And we're going to end on that. So, no fair elections, right? Not here. I will see you back next time.